charade with his friends. My grandpa used to have this little organizer in which his pills were sorted so that he wouldn't mix them up. There were several beta blockers against high blood pressure and phenodorol against his asthma. He was also suffering from Parkinson's disease, which would add another 5 to 7 drugs to the list. You may be wondering, Rita, why are you telling us all this? Well, all those drugs my grandpa used to take were targeting a specific family of proteins in his body. This protein family is called G-protein coupled receptors. In fact, 1/3 of all drugs on the market today target those receptors. However, many of the drugs come with side effects. Others become less effective when taken every day and over a long period of time. But to improve drugs targeting G-protein coupled receptors, it is crucial to better understand how those receptors work. We know that G-protein coupled receptors sit on the surface of almost every cell in our body. Their job is to transmit messages from the outside to the inside of the cell through a series of different motions. You can almost think of a G-protein coupled receptor as a college student. Let's call him Tommy, playing a game of charade with his friends. Tommy receives a card with a phrase on it. He then executes a series of different motions, and as he's very good at the game, his friends understand what Tommy wants to tell them. How does Tommy decide what motions are the best to convey his message? We don't know. Similarly, we do not entirely understand how G-protein coupled receptors convert a message into motion to transmit it from the outside to the inside of the cell. And that is what I intend to find out in my PhD research. I developed a computational pipeline that allows us to simulate in detail the motion a G-protein coupled receptor executes after it receives a message to transmit. My pipeline gives us many three-dimensional models, which we can use to find drugs that act on the receptor and either block, accelerate, or modify its motion. This way, we can correct faulty messages that are sent to the cells in our body in case of a disease. I hope that my computer simulations will help us to find more efficient drugs against a wide spectrum of diseases, so that in the future, when one of us suffers of one or the other medical condition, we will have better drugs in our pill organizers than my grandpa did.